Well, let's get started. 4.3. Increasing and decreasing. Functions. And the first derivative test. And so before we start, remember how given a graph, make a random picture here. Call this guy F. This will be a extreme point, right? Maximum, minimum, local, maximum, minimum. But if you're going left to right, picture like a little car driving up this hill. If the headlights are pointing upward, then it's increasing at that location. Here we have a horizontal tangent, meaning we have a constant, instead of increasing or decreasing, it would be constant here. Then right afterward, we're going downhill. So here we are decreasing. So all along this section, right, we have negative derivatives. Here we have another here the derivative would be 0. But the slopes would be neither decreasing or increasing. So after, headlights are pointing up again, so increasing. These are just ideas from college algebra. So given a graph, you can see where it increases, decreases, increases, right? So you can use the derivative, knowing that the derivative is 0 here. And if you test around it, I can figure out, okay, where am I increasing, where am I decreasing? Because derivatives would be a positive here, derivatives would be negative there, and positive there. So I can answer questions like this. Identify the open intervals on which the function is increasing and decreasing. Okay, so here's the function they give me. So the first step is take the derivative. So the derivative would simply be 2x minus 6, right? Step 2, find the critical numbers. And we did that last time by setting f prime to 0, right? So set this guy to 0 and solve. So that'll be 3, right? Okay. Step 3. Use the first derivative test to test around the critical number. To determine if it is a max slash min, and to find the intervals for increasing slash decreasing. Find a space here. So we'll do on the next page in just a second. Okay, the next page. So you take the critical number, we found it to be 3, right? Yeah. So this is the critical number. So what you do is just pick any number below. I don't know, I want to pick 0 and 4. Plug them into the derivative. The derivative was 2x minus 6. So it'll be 2 times 0 minus 6, which is negative 6. So we're negative over here. G prime of 4 would be 2 times 4 minus 6, which would be 2. So positive. So that means that we're decreasing all the way until we get to here, and then we start increasing right after. Okay. So we are increasing from three to infinity, everything after 3, and decreasing from negative infinity all the way until 3. Now, based on this shape, right, if I'm coming down and then upward, this is a minimum. So we have a minimum at 3 comma whatever the y value is. To find the y value, you would have to do f of 3, which would be x 3 squared minus 6 times 3 minus 16. That'd be 9 minus 18 minus 16. Be 25 negative. Anyway, does that make sense? Okay. So there's a max, then ask for the max minimum, but while you're doing this, you end up getting, while you're doing these two, you're gonna find that out anyway. So this right, what we did right here is called the first derivative test. You find your critical number, you test below by just plugging in any number below the critical. If it is negative, then we're decreasing there. You test a number after, if it's positive, then you're increasing here. So that's it. If you have more critical numbers, then you might have a change in from increasing to decreasing. So if we were to graph this, I mean, it was just a basic parabola, right? So so you can see right here the minimum, decreasing from the left side all the way until 3, increasing right after. So if you graph it, you can get on the information right away, but you do have to show all your work and apply the derivative. The point of this section is to apply the derivative to find out about increasing, decreasing, and to find maximum and minimums. Any questions on this first example? All right. Let me show you the homework. So we did the first one right here. Number 2 and 3 is the same type, is the exact same thing. They just have a different function. So you would have to take a derivative of this and then do the exact same thing. Take the derivative of this guy and do the same thing. Find your critical numbers, test before, test right after, and you'll find your intervals. Let's do another one. Let's see. Let's do number 6, I guess. So given f of x equal to x squared minus 4x. Part A, find the critical numbers of f. So step 1 is you take the derivative. That gets us to here. Set it to 0. Add the 4 over, divided by 2. Looks like we only have one critical number. So similar to the last example. Very similar. So critical at 2. Part B. Find the open intervals of increasing/decreasing. All right. So what you're gonna do is just test around your critical. So there's 2. I'm gonna choose an easy number, 0, and the smaller the better, 3. So plug these numbers into the derivative. So the derivative was this guy. So find f prime of 0. That'll be -4. F prime of 3. That'll be what? 2 times 3 minus 4. 6 minus, that'll be 2, right? So positive over here, negative over here. So we're decreasing from -infinity all the way until 2. Then right after that, we're increasing. That's what this is telling us right here. So now we can answer the question. Increasing from 2 to infinity, decreasing from -infinity until 2. Okay, part C. You guys okay so far? Any questions on A or B? Okay. Oops. So apply first derivative. My first derivative to find max or min. Could be global, could be local, or absolute, whatever word they used. Depends on the book we're reading. So we can see it right here, right? It's another minimum. Because if it was increasing and then decreasing, that would be maximum. So we have a maximum at 2, comma something. To find the, I'm sorry, I just said minimum though. Right. So to find the y value, just plug 2 into the original. Okay. So we basically did B and C at the same time because I applied the first derivative test to answer B, which gives us C. The only thing is they want a point, so make sure that you plug in the y, the x value to get the y, because they're going to want the pair. Any questions on number 2? Okay. Let's do another one of these. Then we'll move on to something else. Number 9 looks annoying. Let's do that one. Given f of x equal to 5 minus x times x plus 1 squared. Find the criticals. So first step is find derivative. So that'll be a product rule. Right? Derivative of the first times the second plus the second times the first times the derivative of the second. Derivative of this is a 1. That doesn't do anything. Derivative of this guy would be a chain rule. So you bring the 2 down, subtract 1 times the derivative of the inside, which also does not do anything. So this will be x plus 1 squared plus derivative of that. Oh, this is a 1. So that'll be, put the 2 in front, x minus 5 times x plus 1. All right. So right now, I could FOIL this out, but I'm going to factor x plus 1 out of both of them. I think that'll be easier, less work. So I'm factoring this out, and that leaves me with 1 of these plus 2 of these. So that'd be x plus 1 plus 2x minus 10. So x plus 1 times 3x minus 9, right? There we go. Set this to 0. This is the next step. So that means we have x plus 1 equal to 0, 3x minus 9 equal to 0. So x is negative 1, x is 3. All right, so we got 2 critical numbers this time. All right, so part B. Find the open intervals for increasing / decreasing. So do the same thing. Just do the first derivative test. Here's my negative 1. Here's my 3. These are the criticals. So I got to test before, in between, and after this time. So I'm going to choose the easy one, 0. And things that are close to these. So these will be the 3 test points. So plug them into the derivative and see what happens. The derivative is equal to this. So it's going to go here. So negative 2 plus 1 times 3 times negative 2 minus 9. That gives us negative 1 times negative 3 minus 9, which is negative 1 times negative 12. Positive. So we are plus over here. right? Let's double check my math here. -2 plus 1 is -1. -2 goes into this 3 here. So 3 times that is -6 minus 9. Oops, yeah, I made a mistake. -6 minus 9. That would be what? -15. Okay, so still positive, but there was an error there. All right. Now we test 0 to do the same thing. That'll be 0 plus 1 times 3 times 0 minus 9. That will become 1 times -9, which is a -9. So we're negative in the middle. Now let's see what happens afterward. After this critical point, plug in 4. That'd be 4 plus 1 times 3 times 4 minus 9. That'll be 5 times 12 minus 9. 12 minus 9, what is that? 3, right? 3 times 5, positive. Okay. So all this work is to figure out if we're positive or negative. So we're plus, so we're going up from here. And then right after we're going down, then we're going up again. Okay. So you can see that there's a maximum over here and a minimum over here. I didn't leave enough space to draw, but is this part clear? So you can write the answer for increasing, right? We are increasing before -1. So negative infinity all the way till -1. And then I start to decrease, but then increase again after 3. You see that? So you're going to put 3 to infinity. And then we're only decreasing in the middle, -1 to 3. Any questions on part A or part B? All right, so now we can answer part C, no problem, right? Find max and min, be global or local. If we look at the picture, we have a maximum at -1, minimum at 3. So minimum at, oh, damn it. Smeared that. Maximum was -1. Okay. -1 right here. So same deal, find the y values by just plugging it into 3 or into the f. So that'll be the original 5 minus 3 times should be 3 right here. Yeah, 5 minus 3 times 3 plus 1. That gives us 2 times 4 squared, which is 32. This would be 5 minus a -1 times 3 minus, oh, shit. -1 plus, dang it, sorry. Fix this. It's because I don't have the function in front of me. That's going to be 0, right? -1 plus 1 is 0 times that, 0. So this will be 0. This will be 32. Well, let's graph it so we can see what we're talking about. The original was x squared minus 4x. Right? No. Wasn't it? Let's see the last question. Was x minus 5 minus x times x plus 1. So minimum, -1, 0 is what we said. No, actually. We said that was a maximum. -1, 0. X plus 1 squared. Interesting. What happened? $332. Could be the max. That means something went wrong over here. So the graph will always tell us the answer, the big picture, right? Literally. So where did our theory here go wrong? The derivative should be, okay. Oh, I see what I did. Got dyslexic. So what happened? This is 5 minus x. I changed it to x minus 5. This is not a huge change, but kind of messes stuff up. So there should be an extra minus sign right here. It should be -1. Change all the x minus 5s to 5 minus x. Okay, this should be a negative right there. These should become both negative. I got lucky that the criticals turn out to be the same. That's interesting. Cool. All right, so that's fixed. So the derivative should be negative, positive. So this should be plus 6 minus 9 would be, this would be different. Yeah. So 6 minus 9 is negative 3. So in this case, it didn't matter. Still positive over here. So this part's good. Double check one more time. Yeah, let me just erase this line right here. Sorry, guys. Sign errors can really mess you up. A small little error at the beginning just has a domino effect. So this should be positive 6 plus 9. So this should be negative. So there's my mistake. Draw a minus over here. Okay. This would become positive, positive. So plus right there. This will become negative 12. This become negative. So negative 15. There we go. Finally, geez. So we're decreasing, increasing, decreasing. So now it fits the picture, which means these need to be swapped. And we're good. Anyway, is there any question on this? And I don't know if hopefully it didn't cause any confusion. Because the issue came because you can see on this picture, right? It is decreasing here. Right after the horizontal, it starts to increase. And I had this side increasing, which did not fit at all. So I had to go back and check my work. So whenever you finish, graph the function and see, like, does it fit what you're talking about? And if it doesn't, then see where the error is. Okay. That's pretty much for 3 and the first derivative test. So all you need to do is be able to find critical numbers, which we did last time, 4.1. And then figure out where you're increasing and decreasing. Figure out where your max and minimums are located. But make sure you use the derivative. Actually go through the steps and the work. Because yeah, these can be found pretty easy by graphing, but that's not the point. You need to show all the work that we just did together. The same stuff will be done on test, test 3. It's just nothing but chapter 4 stuff. Okay. Any questions on 4.3? All right. So let's stop here then. So we did 4.3. 4.2, as I said, I'm not going to really go over this section, but I want you to read it. It's an interesting theory that basically this allows you to build you build on top of it to create the first derivative test. So all these applications we're doing is because of these two theorems. But I'm not really requiring it. I just want you to be able to apply it. Okay. So so Thursday we're gonna do concavity, and then the limits of it at infinity. And then the following Tuesday we're gonna have curve sketching. Okay. That was.